Good morning, good afternoon, ladies and gentlemen. Welcome to another series of online lessons with me. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we are looking at the last part of set theory that we're going to look at, which involves axioms. All right, so these are axioms. Okay, axioms. So, what are axioms? So, axioms can be thought of as basic principles. Okay, so basic principles, or maybe we can call them basic facts. Okay, so these are axioms. Now, axioms are very important because they will help us simplify set operations or set functions, or so to say. Right, so the first axiom that we'll look at is where we have a complement. So a complement, we want to get rid of the complement, we subtract from one, like that. Okay, so when you have a complement like that, you just subtract from one to get rid of the complement. So now this will be helpful in cases where we'll be required to, maybe if we want to get rid of the complement, we just say 1 minus the complement. Right. So the second basic fact is that, okay, so we'll say this is fact number one. The fact number two is when you get a set A complement and you intersect it with the set A, what will they have in common? So let's visualize this. So A complement, if this is A complement is outside here and A is here. What do they have in common? So this gives you an empty set. Okay, so this is another axiom. Then axiom number three, if you have A, the set A complement, and A, what are you going to get? You're going to get the universal set. Okay. The fourth axiom is that if you have A union B, this is basically equal to A plus B minus A intersection B. Okay, so for these, we'll give a brief proof for each of these, then we'll see how we'll move on from there. I think other axioms that we can include here is maybe where we have A intersection the universal set. So what does A and the universal set have in common? Well, it will give us A. Axiom number 6, we can say A union the universal set. This will just give us the universal set. So these are some basic axioms that you should know that will help you simplify set operations. Okay, the other one is not really an axiom but rather a theorem. It's called De Morgan's. So De Morgan's states that if you have A intersection B and these are complements, you can break this down as the A complement, then the sign changes to union B complement. Okay, vice versa can work too. So if you have A complement intersection B complement, so if we want the complement to come outside, as the case, we're going to have A. Now this will change to union B, then the complement comes outside. So when you take the complement inside, it will be A complement, then this will change to intersection if it's union, and union if it's intersection, then B complement. So just like that. So this is one of those important theories. Okay. All right, let's look at the last two axioms. So the other one is about independence. So if A and B are independent, so if A and B are independent, then the probability of A intersection B is basically equal to the probability of A times the probability of B. Okay, so this is independence. If A and B are independent, then A intersection B is basically equals to A times B. So we can simply say A intersection B is equal to A times B. Okay, so that is for independence. Okay, the probabilities are equal to each other like that. Okay, then the other one is for mutually exclusive events, meaning that mutually means at the same time, exclusive meaning not happening. So mutually exclusive events, so that is number 8. If A and B are mutually exclusive, if A and B are mutually exclusive, then A into B is equal to 0. Okay, if two events cannot happen at the same time, meaning that they will have nothing in common because they cannot happen at the same time. So that is for mutually exclusive events. Okay, so all these axioms are provable, but there will be no need for that, but you can write them down so that we learn how we can use them. So if you have A complement, this is the same thing as 1 minus A. And usually we are trying to get rid of the complement in whatever function that we're trying to simplify. We're trying to get rid of the complement. So if you want to get rid of the complement, you just say this is equals to 1 minus that thing A. Okay, then when you have A complement intersection A, this is an empty set, which is just basically equal to 0. So this is equal to 0. Then A union A is basically equal to E. I think another axiom that I could add, which we'll call number 9. So we'll call number 9. That is the probability of the universal set is equal to 1. So what we mean is the probability of getting a number from the universal set is just 100%. Okay. Yeah, so the probability of the universal set is 1. So you can write all these axioms down. Then let's see how we can use them to simplify set operations. All right, so let me just give a demonstration here. So you are asked to simplify the following operations. All right, so there'll be more questions for you. So you have these operations, and now highlight some rules or axioms that I did not put there that you should know. Okay, so for instance, we have this here. Now, what you should know is that you can, let me say x. Where should I write? Let me write here. What you should know is that x intersection y is the same thing as y intersection x. So you should know this. Then here what we can use is the distributive property. Okay, how you use the distributive property is you get the x and this intersection the y and that. So we'll say x union x intersection y prime. Then we use this intersection, which is intersection y union this. So just like we do it with the distribution property. All right, so y prime. Okay, then now from here we know that we want, here we can use the grouping method. We know that A intersection B union C, for instance, like that, is the same thing as A intersection B then union C. Okay, so this is a correlative like that. So what we can do is we can regroup the two parts here. So this can be grouped. See, so these two can be grouped. This would be X union X grouped like that. Then there is an intersection here. So intersection Y prime. Then there is this intersection. Then here we can change this. So we say Y union. This it can be written as y prime, starting the y prime, then intersection x. Okay, then again we're going to do the same thing that we did. So let's put equals there. So x union x, x plus itself, what do they have in common? It's just x. So x union x is just x, then intersection y prime, okay, or y complement, then intersection, then these two can be grouped like this, okay, which is y union y prime intersection x. Okay, now what is y union y prime? So let me give you a visual of this. So if this is the set y, outside y it will be here. Okay, outside y will be here. Union means adding with the inside of y. The inside will be here. So outside y plus the inside of y will give us the universal set. So this is universal set. So this will give us the universal set. Intersection x here. Then here we have intersection. Then we have x intersection y prime. Okay. We are still moving. So here, what is x intersection e? Okay, so what does x and the universal set have in common? Well, they have in common x. Okay, so x intersection the universal set is just x, so this would be x intersection. So this part can also be rewritten. Remember what we said, x intersection y prime is the same thing as y prime intersection x. So this can be written as y prime intersection x, like that. Then by the commutative call, we can group these. So this would be y prime intersection, then we group x intersection x. Okay. Now, what does x and x have in common? So that is basically x intersection y prime. So this is the final answer. So basically, all this that we've been doing here is just simplifying y prime intersection x. So which is this? And further, this you should also know that y prime intersection x is just equal to, okay, let me just give you a visual of this, then you'll be able to see. So y prime, so if this is y and this is x, y prime will be outside of this entire set, including this part here. Okay, that would be y prime. So that would be the part there and the outside here. Okay, now y prime and x, what do they have in common? So they have in common this part here. Okay, so they have this part in common, which is basically equal to y, or maybe say x minus, so this is basically equal to x minus the intersection of y and x. So x minus y intersection x. Okay, so this is this axiom. It's also an axiom, so it can be written like that as well. So this is that. Okay, so basically that's it. Now let me give you an example to try out. So try to simplify the following question, then I'll give you more questions later on. All right, so you try to simplify this. That is A intersection B union C intersection A complement intersection B complement. So try to simplify this, then we see how we move from there.